Okay, so today's video is going to cover the eye. I'm going to preface this with saying this is being recorded in the science office right by the hallway near the cafeteria. So I apologize if there's some louder background noise, and we'll just kind of do the best we can with this. I also want to say there are only 3 slides in this. While that sounds like it's not a lot, it kind of is. So as you're moving through, don't write super huge. Like keep in mind that I have the ability to write on this diagram, quickly erase it, write again on the diagram. You don't. So maybe every time we talk about something, don't fill the whole diagram. Realize that the list in the corner there, where it says conjunctiva down through nasolacrimal duct, we have to go through all of those. So if you've gotten through the first couple and you've filled your whole diagram, you're writing too big, okay? All right, let's start with the eye, and we're going to focus first on external structures. So these are going to be the structures on the outside that are helping to protect the eye. Your eye is surrounded by the bony orbit, and that bony orbit is going to be made of the following bones: many friendly, zebras, enjoy, lazy, summer, picnics. And if you think back to facial bones and such, right? Many is going to be our maxillary. Friendly would be that frontal bone. Zebras would be the zygomatic. Enjoy would be the ethmoid bone. Lazy would be the lacrimal bone. Summer would be that sphenoid bone, that one that's shaped like a butterfly, kind of on the inside. And picnics would be the palatine bone on the bottom. So this is the bony part of the eye that is going to protect and surround it here on the outside. Okay, so what you guys need to realize is that, again, I've got my bony orbit here, and you need to get down, oops, sorry about that. You need to get down these bones here that make up the bony portion of the eye. Okay, and so the mnemonic there will hopefully help you to do that. Okay, so in addition to the bones externally on the eye, we have the eyebrows and the eyelids. Okay, eyebrows, eyelashes, eyelids. So the eyebrows and the eyelashes, okay, so they actually have a job. They help protect us from dirt and dust. Eyebrows in particular will help protect us from sweat, right? Your eyebrows arch over your eye like that. And so as the sweat runs down your forehead, they actually arch for a reason so that the sweat will then run off to the side, trying again to angle it out and away from your eyeballs. Your eyelashes also are going to help with dust and trapping particles, keeping them from getting into your eye. Okay, so our first kind of new one, hope that maybe we're not as familiar with, is our conjunctiva. Okay, the conjunctiva is the pink part on the inside, so right in here, on the inside of the eyelid. So if I was looking at an eye from the side, right, there's the nerve sticking out the back of the eye. This is the colored part on the front of my eye. So if I'm looking at an eye from the side, right, my eyelid is going to come down over the eye. We're going to give it some nice eyelashes, right? And I've got it on the back as well, right? There's on the bottom. There's my eyelid. And so the conjunctiva is a membrane that lines the inside of the eyelid and then doubles back on itself on the actual eyeball itself. So it's the membrane here. If you had that, like if you're at the bus and that gross little kid that would like flip their eyeballs inside out, right? Not their eyeballs, but their eyelids inside out. They were showing you the conjunctiva. So again, it's the membrane that's going to line the eyelid, cover the eyeball. Okay? It's going to offer a layer of protection. All right, the eyelid. So hopefully we can identify the eyelid, right? We have an upper eyelid and a lower eyelid meant to help, again, protect us, blink, keep things out of our eyes. Okay, and then we have this medial and lateral canthus. Okay, that's where all that is where the eyelid comes together. So the medial canthus is going to be right here, where the eyelids join medially, and the lateral canthus will be out here on the lateral edge, where the eyelids join at the lateral corners. All right, so next we have the things associated with tears, and that is this whole section right here with our lacrimal gland, canal, sac, and nasolacrimal duct. So let's talk real quick about what they do. The lacrimal gland is going to be what actually produces the tears. And then the other three, in summary, really all they do is drain them. So the actual production of the tears is happening in the lacrimal gland. The lacrimal gland is located right here. So let's draw a line there. So my lacrimal gland is located right there. It is located superior, so above, and lateral, again, out to the outside edge. So superior and lateral to the eye is where I'm going to find that lacrimal gland. Again, that lacrimal gland will produce and secrete the tears. Tears are important for us because tears are going to do a couple of things for our eyes. They're going to help lubricate the eyes, so help reduce friction, help prevent that dry eye kind of feeling. They will actually help clean the eye. The tears are going to have lysozyme in them. Lysozyme has antibacterial properties that will help clean out the eye, as well as antibodies in the tears. So every time we blink, what we're doing is we're helping spread the tears across our eye. Since they start over here on the superior and lateral edge, when we blink, we help spread them across the eye like that. Okay, so those tears are really beneficial for us. And as we spread them across the eye, we spread them over to the lacrimal canal. Okay, the lacrimal canal is here where they're going to drain. Okay, so the lacrimal canal will help drain those tears from the eye into the lacrimal sac. In case you're not catching on, lacrimal is tears. All right, so here's the lacrimal sac, and then here's the nasolacrimal duct. And that's going to be our final draining place for the tears. And it's going to actually drain down into the nasal cavity. That's part of why when we're crying, our nose gets stuffy and we can feel things running down into our nose there. Okay, so sticking with the outside of our eye here, let's focus on these muscles. So these are what we call extrinsic eye muscles. So they're on the outside of the eye. They're attached to the white part of the eye here. Okay? And so these are what help us look around. They help us look to the right, look to the left, look up, look down. Okay? These extrinsic eye muscles. Okay? If you remember, rectus, the word rectus means straight. And we talked about rectus abdominis, those straight abdominal muscles. Okay? And so the names of these muscles will kind of tell you where they are. So let's orient ourselves first here. So on this picture, this is our nose here. Okay? So what we're looking at in this picture, picture A here, is we're looking at a right eye. And the right side of the face, the temple, okay, that's been removed. So we're seeing the nose and the eye there, the right eye. Picture B here, okay, this is the nose right here. And we're actually looking down on, again, a right eye. And we're looking down on it. So hopefully orienting ourselves a little bit will help us really be able to see figure out what we're looking at here. Okay, so these rectus muscles, they're all straight muscles, meaning they run in a straight line. So when they shorten, they're going to move the eye in the exact direction that the muscle moves. For example, let's start with this one right here. So this one right here is my lateral rectus. It's on the lateral side of the eye. And when that muscle shortens, because it's in a straight line, it's just going to move the eye that way. So if this is my right eye and I'm looking straight ahead, when that lateral rectus muscle contracts on my right eye will pull out towards the right, straight out to the right. Okay, so what we need to keep in mind with these muscles is being able to identify them and being able to tell what they do, right? The fact that this pulls to the right. So then going through our rectus muscles, if I have a medial rectus, it will pull the eye medially. And we don't say left and right for what direction it will pull it, because my lateral rectus for my right eye will pull my eye to the right, but my lateral rectus for my left eye will pull my eye to the left. So we say it pulls the eye laterally, it pulls medially. So the medial rectus is this one tucked in back here. There's the medial rectus. It's going to pull the eye medially. So if I look at this picture where I'm looking down on top of them, on picture B here, this is my lateral rectus here on the lateral side, pulling my eye laterally. And this one here is my medial rectus, pulling my eye medially. The superior rectus is going to be I'm going to change colors so it doesn't get too messy looking. Superior rectus is going to be this one right here on the top. Okay, and so that would be right here. So the superior rectus is going to pull the eye up. So when you look up at the ceiling, when people say annoying, stupid things, right, that's going to be your superior rectus, pulling the eye superiorly. The inferior rectus is going to pull the eye inferiorly. So it's this one down on the bottom there. Again, because these are straight line muscles, they can't really make the eye roll around or move different directions or anything like that. Where it gets a little different is with these oblique muscles. Oblique means that they come at an angle, right? So these aren't going to pull the eye in the exact direction that that the muscle runs. So my superior oblique is going to be this one right here, runs at an angle like this. It hits that angle. There's my superior oblique. The superior oblique is actually going to pull the eye inferior and lateral. So if you think about it, again, muscles pull when they contract. So this muscle that's attached like this, when it contracts, it's going to pull. Okay, and so that will actually make the eye kind of roll down and out like that. So this one here is my superior oblique on picture B. My inferior oblique is going to actually pull the eye superior and lateral. So you'll notice both obliques are going to pull it laterally, and then they just pull it the opposite of what their name says. Superior oblique pulls it inferior and lateral, inferior oblique pulls it superior and lateral. Okay, so my inferior oblique I can see on this one here. See how it wraps around, attaching, and then it will bend on the other side of the eye. And so that will end up, I'm going to turn it to red here, that will end up spinning. When it pulls, it spins the eye like that. And so it makes you look up, superior, and lateral. And we have a model in class where I can show you if this isn't, making a lot of sense. And as we move further into nerve things, we'll talk about what nerves control these, and we'll revisit these muscles there as well. Okay, so this is the diagram that's going to get a little bit busy. So just kind of be aware of how large you're writing and what you're working with. I think, probably going to cut some stuff out to just make it, because we're on such a short time frame for getting the eye stuff done. And I'm going to try to continue to move through pretty quickly. Okay, so we're going to start with the eye and the fact that it has these 3 layers. So you'll see these this tunic here, fibrous tunic, choroid, retina. Those are the 3 layers of the eye. They're all called tunics. So I have this fibrous tunic, the choroid, which is called the vascular tunic, and then the retina, which is called the sensory tunic. Because where all the nerve all the nerve stuff is. So tunic is just another term for layer in the eye. So starting with the outside of the eye, we've got the fibrous tunic, which its job is to do kind of what it says. It's hard and it's tough, and so it's meant to protect and support the eye. And so the fibrous tunic consists of 2 parts. It's the sclera, which is the big main white part of the eye. And then I don't know if you can see it on your black and white diagrams, but it kind of has a break right here. So everything behind this is sclera. This is all the white part of the eye. And then in the front is the cornea. the cornea is clear and it has no blood supply. And that becomes relevant because one, if you get a scratch on your cornea, it can be a little bit harder to heal because there is no blood supply. Okay. And two, though, it needs to be clear, otherwise light won't come through it. And if no light comes through it, then you can't see anything. So the front part has this cornea layer on it to help protect it. But again, it's clear so that light can pass through it. So our next layer, the vascular tunic or the choroid, is going to consist of a variety of parts, but it's this layer right here. Okay, so this choroid, this blood supply layer, the red right there, okay, that all has the blood supply, and it makes the inside of the eye be really dark. When you do your dissection and you open up the eye, you'll see it's very, very dark on the inside, so the light doesn't bounce around. If the light scatters and bounces around, we can't process a clear image. So we actually need the light to only come into one place, and we need where it's entering, once it enters the eye, we need the eye to be dark so that the light doesn't bounce around in there. So within this vascular tunic, we have this choroid blood supply layer. We have the ciliary body, which is these things that look kind of like goopy little like sea creatures. So that's the ciliary body. We have the pupil, which is the actual opening right here that the light comes through. So there's the pupil, the lens, okay, and then the iris. And the iris is the colored part that's going to surround the pupil. So we'll talk about each one of these for just a second here. So again, the iris is the colored part that surrounds the pupil, and it controls the size of the pupil. So this is what basically controls the amount of light that is let into the eye. Okay? Again, the pupil is literally a hole. It's an opening. Okay? And so the iris surrounding that hole dictates how much light comes in and out. You know, when we shine a bright light in our eye, it gets narrower so it doesn't damage our eye. When we're in a dark space, it will expand out to let as much light in as possible. The lens is right here behind the iris. Okay? The lens is held in place by these little ligaments here, these little suspensory ligaments. So they hold the lens in place and they help adjust the lens. Okay? Those suspensory ligaments are attached to the ciliary body, and they'll help change the shape of the lens. When we change the shape of the lens, that is going to help focus the light. What we want is for light to come in through the eye and focus right here on the back of the eye. So depending upon where the object we're looking at is located, and the light that's bouncing off of it, we may have to change the shape of the eye so that we can bend the light more. Maybe it's already coming in nice and flat because it's far away. Maybe it's really close and we need to make it bend a lot. Okay? But the changing of the shape of the lens is what's going to do that. Okay? And that ciliary body, again, helps change the shape of the lens so that it can focus that light. And when we do that, we do this process called accommodation. And accommodation is where the lens gets really thick. And so it's what bends the light lots and lots so that we can see up close. So accommodation is when the lens will thicken up so that it bends the light and we can see up close. Okay, and so the last thing that we need to talk about here is the sensory tunic or the retina. So basically how we actually get an image and how we process the image and the fluids that are part of our eye. So I'm going to clear a lot of this out, okay, so that it's not so messy for you. Okay, so now that that's cleared off, let's start now again fresh with this retina. Okay, so again, the retina is also called the sensory tunic, so the sensory layer there. And the retina is only on the back part of the eye, and it's going to be this layer right here on the edge that is actually, even though it's in the back of the eye, it's anterior to the choroid. So the retina is going to contain our rods and cones. And rods or cones are are what are actually responding to the light. So rods are important for us when we're in dim light. So we don't have great light source. They help us a lot. We see most things in black and white when we're using the rods. And they're really helpful with our peripheral vision. So these are not like what I'm using right now as I sit in here in this well-lit room and I'm looking at the multicolored computer. Okay, I'm using the cones for that. And so the cones are what are triggered in bright light, and they help us do our color vision. Okay, and so these are ideal. This is where we get the sharpest, crispest, most crisp images, is by triggering those cones. So again, good quality light with those. And ideally, we can get an image focused right here on the back of the eye. So right here on the back of the eye, this area here is called the fovea centralis. And the fovea centralis only has cones. And so since it only has cones, it is where we get a really high level of visual acuity, meaning this is where we get our sharpest vision or our highest visual acuity is here. If I can get the light to come in and to focus right here on this fovea centralis, that's my best picture that I'm going to get. Okay, and so let's follow the path of light for a second. So the light will come into the eye. Okay, it will stimulate the rods or cones. And so now that information is going to travel down the optic nerve. The optic nerve is this big giant yellow thing that's sticking out in the back here. Okay, so that's my optic nerve. It's also called cranial nerve 2, and it's going to head to the brain. So the optic nerve is then going to pass the message down the optic chiasm. The optic chiasma is actually what's going to allow information to cross. Some information will cross from the left eye to the right side of your brain. Some will cross from the right side to the left side of your brain, which is important because that helps us get our three-dimensional pictures. From there, the message will travel down what we call the optic tracts, and then it will head into your brain, into the thalamus. That's an M, that's a U. So into the thalamus, and then into the occipital lobe of the brain. And again, we'll talk a little bit more about this as we get into the actual brain, but this is the basic pathway that the message will follow. So the light comes in, triggers the rods or cones, message travels down the optic nerve, optic chiasm, optic tracts, thalamus, into the occipital lobe of the brain. This area right here, where the optic nerve exits the eye, that is called the optic disc or the blind spot. Meaning in this location, there are no rods and no cones. So you cannot, even if light hits there, you can't make an image form, okay? Because this is where the optic nerve is exiting the back of the eyeball. No image will form here. So any light that focuses there, we're not going to see whatever it is that the light is bouncing off of. So again, that's why it's called our blind spot. And we compensate for this, and we don't see a blind spot in our everyday life because we have two eyes and we have that overlap of image there. Okay, I'm going to clear everything off one more time and talk very quickly about this vitreous and aqueous humor. Okay, so the last two things are these two liquids here, and we're going to talk about them because you're going to see them in your dissection. So we have the aqueous humor, which is right here. This one is more watery, okay, hence the term aqueous. Okay, so this aqueous humor is a watery fluid. It's going to fill this area right here, what we call the anterior chamber. So from the lens forward. So again, that aqueous humor is here in that anterior chamber, which is from the lens forward. Okay, it's very similar to blood plasma. Okay, it's going to offer nourishment to the lens and to the cornea because again, those don't have a blood supply because they get in the way of the light, okay, and we'd see it. So we need those to be nice and clear. So we bathe them with this aqueous humor that helps nourish the lens. So the lens here and the cornea here, helping keep them healthy. So we're constantly making this, draining it, moving it through here. The vitreous humor in the back here, so the vitreous humor fills this posterior chamber, which is basically from the lens backwards. So this whole area right here is filled by vitreous humor. This is really important for pressure purposes. When you go to the eye doctor and they squirt that air into your eye and they're checking the pressure, they're checking this. This vitreous humor here, okay, is not very liquidy. It's more like a gel. When you do your dissection, it'll like fall out in a big hunk, like a gel. Okay, so it's a gel-like substance. It's going to fill the posterior chamber. It holds the retina in place. Okay, so the pressure that it exerts on the walls on the back of the eye here help hold the retina in place so it doesn't collapse down. And this is not constantly being recycled, constantly being made. This is there from the time you are born and it lasts a lifetime. Okay, so that wraps up our eye. Okay, I know it was really quick. We'll practice a lot with it in class as much as we can next class, over and over and over. And then we'll do your dissection the class after.